So I'm Eric. Today I'm going to be talking about proof by induction. So the general idea behind proof by induction is that for some property P, you want to prove that P of n is true for all positive integers n. And so proof by induction happens in two simple steps. The first step is the base case, where you want to prove that P of 1 is true. And then the second step is the inductive step, where you want to show that P of k implies P of k plus 1 for some arbitrary integer k, arbitrary positive integer k. And I'm going to show how this works with an example. So let's say you wanted to prove that for any positive integer k, you can make exactly k dollars using only quarters. Now, this is like a really basic example. You can immediately see that this is true just by looking at it. But I'm going to show how you would prove this by induction. So let's let P of n be the statement that you can make n dollars using only quarters. Alright, so for your base case, all you need to do is prove that this is true for P of 1. So in other words, that you can make $1 using only quarters. And so for this base case, we can just say we can make $1 using 4 quarters. Therefore, P of 1 is true. And it's that simple for the base case. So now for the inductive step, what you need to do is you need to assume P of k, where k represents some arbitrary integer, and you want to prove P of k plus 1. So in this specific example, we're assuming P of k, so we know that we can make k dollars with only quarters and we know that we can make the additional dollar. We can make $1 with 4 quarters. And therefore, we can make, putting these two together, we can make k plus $1 with only quarters. And therefore, P of k implies P of k plus 1. And that completes the inductive step, and that completes the inductive proof. So now the way that these two steps work together is you say, I can make $1 using 4 quarters, that's my base case, and then I can make $2 using only quarters because I can make $1. So like the previous step implies the next step. So you can make $2 because you can make $1, and you can make $3 using only quarters because you can make $2 using only quarters, and it builds so on. You can make 4 because you can make 3. 4 implies that you can make 5. 5 implies that you can make 6, etc., for every integer. And so that's how these two steps work together. One important thing to notice is that when you're doing the inductive step, you want to use your assumption that P of K is true in order to prove P of K plus 1. So like this particular example is like super simple. Like I could say, just for an arbitrary value of K, I can make K dollars using 4K quarters, or I can make K plus $1 using 4K plus 4 quarters, but that's not really induction. The point of induction is to use like the previous value to prove the next value. So like your defense for why, P of 11 is true is because P of 10 is true, and P of 10 implies P of 11. And then you would say, well, P of 10 is true because P of 9 is true, and P of 9 implies P of 10. And that would, go on until you reach your base case, in which you can just say P of 1 is true because I proved it right here. So you want to make sure that your inductive step uses the previous value to prove the next value. You don't want to just, try to directly prove that P of K is true without using this assumption, because it won't always be as straightforward as this problem. There will be times when it's not obvious that this proof is true, and induction is the easiest way to make it make sense.